Welcome back to lesson 3 on geometric optics. I want to discuss refraction, refractive index, and optical density in this video clip. So what is refraction? Refraction is the bending of a light ray when it moves from one optical medium into another. Now, refraction and diffraction sounds very close, but diffraction is the bending around of a wave around an obstacle, or when it moves through a gap between obstacles, where refraction is the bending of light when it moves from one optical medium into another optical medium. And it happens when the incident ray is at an angle other than along the normal, the bending. And the reason for the bending is because of the change of the speed when light, or any wave for that matter, enters a new medium. There is a video that I have. You could Google the name of the video and might find it if it still exists on YouTube. So here we have something called an optical illusion. You've got 4 glasses there filled with water. Behind it you've got parallel lines in the background, and the change in the speed of light that comes from the background when it moves into the glass and into and out of the glass and into the water cause the distortion of the lines as we see them there. Next, what is refractive index? Now, refractive index is the ratio of the speed of light in a vacuum, which is the 3 times 10 to the power 8 meters per second, to the speed of light in the optical medium. So we can change the words into a mathematical equation where n is the refractive index, c is the speed of light in a vacuum, 3 times 10 to the power 8, and v will be the speed of light in the optical medium. So refractive index is a ratio between two speeds. The change in speed, and thus the degree of bending of the light, depends on the refractive index of the optical medium. And the refractive index of an optical medium depends on the optical density of the medium. We will discuss that a little bit later. So we can say that the refractive index is inversely proportional to the speed of light in a medium. The higher the refractive index, the slower the speed of light in a medium. Now, refractive index is a way to measure optical density. So we can say the higher the optical density, the higher the refractive index will be. This table compares some refractive indices of different medium. A vacuum's refractive index is taken as 1. Helium is 1.0000036. Air is 1.0002926. It is used as 1. Carbon dioxide is 1.00045. Ice is 1.31. Water liquid at 20 degrees Celsius is 0.333. Acetone 0.36. ethyl alcohol or ethanol for that matter, 1.36, the same as acetones. Fused quartz, which is a type of glass, 1.46, glycerine 1.4729, rock salt 1.516, crown glass 1.52, polystyrene varies from 1.55 to 1.59, bromine 1.661, perspex 1.495, sapphire 1.77, sugar 0.49, glass 1.5 to 1.9 depending on the type of glass, zirconia 2.15 to 2.18, diamond 2.419, silicon 4.01, sodium chloride 1.54. Can't see the 30% sugar solution. So we are going to use some of these to do some calculations of refractive indices and speeds, and we will also we can use them to identify the material involved. So our first example is to calculate the speed of light through glycerine, and I copied the refractive index from the table. So the refractive index is the ratio between the speed of light in a vacuum to the speed of light in the medium. So it's 1.4729 is equal to 3 times 10 to the power 8. What is the speed of light in that medium? Three times 10 to the power 8, excuse me, divided by 1.4729 gives me an answer of 2.0368 10 to the power 8, and we could round it to 2 decimal places, 2.04 10 to the power 8 meters per second. Second example, without doing any calculation, say whether light will move faster through table salt or diamond. So give a reason for your answer. So light will move faster through table salt. The reason for that, the lower the refractive index, the faster the speed of light in the medium. And I get that from N equals C over V. Or we could say N is inversely proportional to the speed of light in that medium. And table salt has a lower refractive index than Right, so first of all, we need to answer the question. Then we need to explain the question using saying that the lower the refractive index, the faster the speed of light. I'm using the equation as well, or the ratio, and then stating that table salt has a lower refractive index than diamond. This third example, calculate the change in the speed of light when light moves from water into glass. Also state whether the light speeds up or slows down. So in water, what is the speed of light? I'm going to change the subject of the formula n is equal to c over v to v equals c over n, which is mathematically correct. So it's 3 times 10 to the power 8 divided by 1.333, and you get 2,25, rounded off to 25, 10 to the power 8 meters per second. In glass, what is the speed of light in glass? So the speed of light is c over n, so it's 3 times 10 to the power 8 divided by 1.5, and I get 2 times 10 to the power 8 meters per second. Now they asked us to calculate the change in speed, so it is the speed from the speed in water to the speed in glass, 2.25 10 to the power 8 minus 2 10 to the power 8. That would give us a 0.25 times 10 to the power 8. Now to write it in scientific notation correctly, it's 2,5 times 10 to the power 7 meters per second, and it slowed down from water to glass. Right, so just 3 different examples of how they can ask questions where you have to use or calculate the refractive index. Lastly, I want to just mention optical density. I've discussed it already, but let's just see the words. Optical density is the measure of the refracting power of a medium. So the higher the optical density, the more the light will be slowed down or refracted, and the higher the optical density, the higher the refractive index of that medium will be. So this corresponds to the equation. Refractive index equals the speed of light in a vacuum to the speed of light in a medium. So the higher the refractive index means the higher the optical density, so the slower the light will move through the medium. This is the end of the third lesson discussing refractive index.